Hello everyone, welcome you to all SL Singh's Mathematics channel. Today will be discussed sample space and events problems. That is, we have to solve some examples regarding sample space and events. So let us start. So check here one question regarding question given. Find the sample space for the following experiment. Here question given drawing of 3 screws from a lot of right-handed screws and a left-handed screws. Then another question is rolling of 2 dice. Then another question is tossing of 2 coins, then rolling a die until first 6 appears. So how we'll solve these problems? This is very simple problem to evaluate sample space and events. So question given, first question is drawing of 3 screws from a lot of right-handed and left-handed screws. So in my previous video, I had discussed regarding sample space. So what is sample space? Sample space means if we write all outcomes in a set, that is called sample space. And what is outcomes? Outcomes means experiments outputs. So here question given drawing of 3 screws from a lot of right-handed and left-handed screws. So if I denote capital L and capital L for left-handed screws and capital R for right-handed screws, then how my sample space looks like? Sample space corresponding to the drawing of 3 screws from a lot of right-handed and left-handed screws. We have to draw 3 screws. So the 3 screws may be LLL, that is 3 are left-handed screws, or 2 are left-handed screws and 1 is right-handed screws, or it may be LRL, that is 1 left-handed screws, 1 are right-handed screws, another is left-handed screws. So like this, we have to write all possible outcomes. Point, if we toss a coin 3 times, then how it looks like. So like this, you have to write all sample space, all outcomes. So if we write all outcomes in a set, then it is called sample space. So the sample space looks like this. Then if you take cardinality, then sample space cardinality is 8. Then in my previous lecture, rolling of 2 dice. If we roll a 2 dice, then how its sample space looks like. So check here. I'll show you here again. Just a minute, I'll show. So if one coin tossed twice, then it look like this. But our question is, this is rolling of 2 dice. One question is tossing of 2 coins like this. Like this, we have to evaluate the sample space. If one coin tossed twice, then or 2 coins twice once, then sample space is look like this. That is HHHT, THTT. If you have any doubt, then refer the previous video. Then if a die rolled twice or 2 dice rolled once, then S is look like this. That is 1, 1, 1, 2 up to 6, 6. Then sample space cardinality is 36, which is equals to 6 square. Then another question, next question is rolling a die until first 6 appears. So this is one tricky question, how you have to solve it. Suppose here we will take P is getting a 6 in rolling of a die. Q is not getting a 6 in rolling of a die. Then S is the sample space corresponding to rolling of a die until first 6 appears. So that is our question, sample space corresponding to rolling of a die until first 6 appears. So how we'll solve it? Because I don't know, or we also don't know how many times the coin, the die roll. But we are taken that P is getting a 6 in rolling of a die, Q is not getting a 6 in rolling of a die. If we roll a die one time, then now if we will get it is 6, then we'll stop there. Then what is that value? That is P. If we die roll 2 times and in first case we are not getting 6, then what will how it is look like? That is Q. Then similarly, if in second time we'll get P, then it is P. Similarly, if we die roll 3 times and 3 times like first 2 are not 6, then third time is 6, then it look like in this way. But we don't know how many times coin that is roll a die. So for that case, S cardinality is infinity. If we if we roll that die 150 times, that means 149 times will not get the 6, then at 150 time maybe we'll get 6. So we stop at 150 case. So like this infinite number of cases arises. So we write sample space in this way. Then comes to our another question. Our question is, find the sample space corresponding to the drawing of bolts from a lot of 10 containing one defective until D drawn, assuming sampling without replacement. That is, bolts drawn are not returned to the lot. That means in a lot 10 number of bolts are there. Out of 10 lots, one is defective until D drawn, assuming sampling without replacement, that is bolt drawn are not returned to the lot. So how you will solve it? So given that a lot of 10 bolts containing one defective, that is D. Suppose in similar manner, here we'll write P is the event that a defective bolt is drawn. Q is event that a non-defective bolt is drawn. As the drawing was done without replacement, that is your question, hence the sample space for drawing the defective bolt will contain maximum 10 elements. Why maximum 10 elements? Because in your question here it's given that is from a lot of 10. That means 10 number of bolts are there. But in previous question, how many times it's not represent? So for that case, we'll continue up to infinite. But here in this question, 10 number of bolts are here. So we'll stop at 10th position. So here, since we are taking P is a defective bolt and Q is a non-defective bolt, so if we take from 10 bolts one bolt and this one bolt is defective, then we'll stop there. That is P, since P is defective. But we don't know in which place that is our defective bolt comes out. So if we'll draw 2 times, that is first draw is Q, another draw, first draw is non-defective and second draw is defective. So it look like QP like this, QQP up to 10th position, that is 9 number of Qs and 1 each. 9 number of Qs means 9 number is non-defective and 10th number is defective. So we'll solve this type of problem in this way. So then in another question, that is in problem 1a, let A, B, C, D mean one right-handed, one left-handed, and two right-handed, two left-handed, respectively. Among three screws drawn, are A and B are mutually exclusive? Then C and D. What is the elements of C and D? We have to evaluate. That means we have to evaluate what is the elements, that is what is the outcomes of A, B, C and D. Then we'll check whether A and B are mutually exclusive or not. So what is problem 1A? Check that question again. So problem 1A is find the sample space for drawing of three screws from a lot of right-handed screws and lot of left-handed screws. And also we had denoted that L is the left-handed screws and R is the right-handed screws. So according to the question, here A, B, C, D mean one right-handed, one left-handed, and two right-handed, two left-handed respectively. That means A contains one right-handed screws, B contains two right-handed screws, C contains two left-handed, B contains one left-handed, C contains two right-handed, D contains two left-handed screws. So it looks like this from this question 1A, you have to check where one right-handed screws are here, here one right-handed LLR, LRL, RLL, then these are your one left-handed screws. So you write in this, then so similarly B is one, so A is one right-handed screws, B is one left-handed screws, C is two right-handed screws, D is two left-handed screws. So we'll write in this way, then check what is the condition of mutually exclusive event. Two events are said to be mutually exclusive if they are disjoint. Also, we had solved so many questions of mutually exclusive event in our previous video. So mutually exclusive, these are disjoint, that is A intersection B equals to 5. So check here A and B, whether some common points exist or not, check here. So no common points in between A and B. So A and B are mutually exclusive, and check for C and D. Is it mutually exclusive or not? So no common points exist here. So C and D are also mutually exclusive. Why? Because A intersection B is 5. And C intersection D is also 5. So that is solved. Then check this question. In rolling of two dice once are in A means sum divisible by 3, B means sum divisible by 5, mutually exclusive. It's given, it's mutually exclusive. Also, it's also a mutually exclusive because sum is divisible by 3, then sum means addition divisible by 5. Answer the same question for rolling of 3 dice. So you have to check in rolling of 3 dice what is its sample space and how it look like. So since here A is the event that sum appeared in rolling of 2 dice, once is divisible by 3. Check here in rolling of 2 dice how it look like. If we roll 2 dice, so elements are look like this in this way 1 1 1 2 1 3. So you take its addition 2, then 3, then 4 up to 12. That means its sum exists from 2 to 12, 2 3 4 5 up to 12. So which term divisible by 3, you have to write in A. Which term is divisible by 5, you have to write in B. So A is the event that sum appeared in rolling of 2 dice once is divisible by 3. B is the event that sum appeared in rolling of 2 dice once is divisible by 5. So these are elements 3, 6, 9, 12 are the sum divisible by 3, and 5 and 10 are divisible by 5. So check here. So these are your A set and these are your B set. So check whether any elements lies in between A and B or not. Since here elements 3, 6, 9, 12 and here elements 5 and 10. So no common points exist. So it's mutually exclusive. Here it's written in this way. A and B are mutually exclusive. But in case of a 3 dice, it's different. Maybe it's mutually exclusive or not mutually exclusive. You have to check that because 5 into 3 is 15. That means that means if we roll a die 3 times, then if you take that type of question in that case, so it is not mutually exclusive. So that's your work. You have to check that portion. And then another question in problem 1b, mark the events A. Mark the events A is the faces are equal, B is the sum of the faces less than 5. Then find A union B, A intersection B, A complement and B complement. That is a very good question. That is problem 1b. What is your problem 1b? Check here. Rolling of 2 dice. So rolling of 2 dice here. Here rolling of 2 dice. These are the sample spaces, rolling of 2 dice. So here question given, mark the events. A is the faces are equals. What is the faces are equals? Faces means 1, 1. That is 2 faces are equal. 2, 2 faces are equal. 3, 3 like this. 4, 4 like this. These are faces are equal. So in A, we have to write this. B is the sum of the faces less than 5. Sum means addition. Sum of the faces less than 5. 1 plus 1 that is 2. 1 plus 2 that is 3. 1 plus 3 that is 4. So you have to take that type of elements in B. So write all these elements in B. So question here A union B. What is A union B? You have to write all elements in a set. That is your A union B. And what is your A intersection B? Check here. 1, 1 is the common point. Similarly, 2, 2 is the common point. So A intersection B is this. Then A complement. What is A complement? A is same faces. B is what? Faces appeared in rolling of 2 dice are not equal. Not equal means you have to write in this way. You have not taken that that is 1, 1, 2, 2, 3, 3. Excluding that part 1, 1, 2, 2, 3, 3, 4, 4, 5, 5. Then you take another point that is 1, 2, 1, 3, 1, 4, 1, 5 like this. So how many elements are there here? There are 30 elements. So A complement cardinality is 30. So in this way, you have to solve this question. Then check another question. List all right subsets of S is A, B, C. What is right subset? All right subsets. Here it's written to find all subset of S as to find the power set of S. As we know, power set contains all elements. How it looks like? First is phi, because phi is subset of S. And A, B, C, then you can take also A, B, B, C, C, A, and the last set that is A, B, C. That is also called all right subsets. That is the same meaning of power set. Then another question, in a problem 1D, list out comps that makes up the event. E is the first 6 enrolling at most 5 times. Describe E complement. That means here problem 1D in above question, in above portion in 1D, how many times we have to toss the coin, we don't know. We have to, how many times we have to roll the die, we don't know. But here it's given that list that outcomes that make up the event. E is the first 6 in rolling of most 5 at most 5 times. So at most 5 times means what? So is so at most, that is maximum, we have to roll 5 times. So that means if we find in first roll 6, so we stop. That is P. If we don't find that in first no 6 will appear, then we'll go to our next roll, that is either it is QP. So maximum we have to write up to 5 times. So E is this, and E complement, what is E complement? Event that first 6 appear in rolling a die beyond 5 times. So excluding 5 times, how many times are there? We have to write it, but we don't know exactly how many times we have to roll the die. So for that case, B complement, that is E complement, not B complement here. E complement is 5. Okay, that is one tricky question. So we have solved that type of question in sample space and events. So that is a very good question. So in next class we have solved, in next video we will solve some problems regarding probability, and we'll discuss I'll discuss some portions of conditional probability and independent events. Thank you all.